So we now have these methods of solving quadratic equations. We have factoring, we have the square root method, now we have completing the square when we have something that's not factorable. But what's even better is to just have one method that works no matter what. It does need a little formatting to get it ready, but it's a formatting that we're used to, meaning we have to have 0 on one side of the equation. But then once we have a 0 on one side of the equation, it's a formula that works no matter what. So it will always find your two values for x that solve the equation. And two values or one value, or we'll even talk about what will happen to this when there aren't any values. So how it goes is we'll have 0 on one side of the equation, and with that we can see our setup of ax squared plus bx plus c. And just keep in mind that sometimes maybe b will be 0, meaning you don't see that bx term, and maybe c will be 0 and that you don't have a constant term. That's totally okay, but you do have to have x squared in there somewhere. So just be sure that x squared is in there because that's what makes it quadratic, but sometimes you'll be missing pieces, and I'll just give values of 0. Now, once we have that set up, we can see our values for a, b, and c, and we can plug them into this formula that will calculate x for us. How the formula goes is we'll take negative b plus or minus, and then we'll have this big square root of b squared minus 4ac all over 2a. Now, memorizing this formula is great, but it's hard. It's not a great formula. If you look on YouTube, there are videos for like songs to help memorize it. But basically, just have it somewhere visible as you're working through these solving quadratic equations. And just the more practice you get with it, the routine kind of gets easier with it. Okay, so let's see how we solve with the quadratic formula and then some different ways that we can format our solutions as well. So we have our quadratic equation 3x squared plus 5x minus 4. What I'm going to make note of is that we have 0 on one side of the equation, so I don't need to move anything around. So what I'm going to do is make note of what is a. Well, a is 3, b is 5, c is negative 4. Now, once I have that set up, I'm going to put together my quadratic formula. So it starts with x equals, and then we'll have negative b plus or minus square root b squared minus 4ac all over 2a. Now, when we have negative numbers, these parentheses are so important. So think of this as your format for the quadratic formula with these parentheses and operations around them. And then we can fill in our numbers. So negative b plus or minus square root of b squared minus 4ac all over 2a. All right, now we start simplifying. So I think of this in terms of 3 pieces. Give this piece to the left of the plus or minus, this piece underneath the square root, and the denominator. So what I'm going to do is go down here and make my fraction with a plus or minus and simplify these kind of 3 pieces to the formula. So negative b, that's just a negative 5, so we'll have negative 5 plus or minus, and then what I'm going to do is simplify everything under the square root. And this is where a calculator will help us out. So let's go to the Desmos calculator, and I'm just going to type in what's underneath the square root. So we're going to do 5 squared minus 4 times 3 times negative 1, which we get a positive 37. And that's because I typed in a 1 instead of a 4, so that's not right. 73, there we go, positive 73. So I have a 73 under there, and then the denominator 2 times 3, which is 6. Now what I would do is I would look at that square root and think about, can I simplify that? Is there anything that I can get out from underneath the radical? But 73 is pretty stuck. That just is what it is. So with that, this could be our final answer right here. This is a possible format for our final answer, so we could leave it just like that. Sometimes what we'll do is we'll separate up our fraction because there might be pieces that will reduce down. So what that would look like is we could express this as, I'll put like a little or right here, or we could write it as -5/6 plus or minus square root of 73/6. That is absolutely a correct way to write that answer as well. And what can be nice is if pieces cancel out, it can kind of simplify down. But this is all pretty stuck in that form. If we were working on a word problem, what we would want is the decimal form of the answer. So what we could do, and typically if we're just solving algebraically, either of these forms is what we want. But just for when we do get to word problems, to show how we would plug it into the calculator, we would want to get the decimal form. So with that, we'll go to our calculator and going to plug in, see, I'm going to make a fraction, and we'll have -5 plus the square root of 73 all over 6. So we can see we'll go to 4 decimal places, 0.5907 is a solution. So I was coming from the addition scenario, and then I just want to do the same thing but with subtraction. So I'm just going to go in there and edit subtraction for a -2.2573. So all of these express the same solution. Again, most often we'll want these exact answers, but if we need the decimal form, we can plug it into the calculator. All right, let's keep practicing. So this scenario, we have 0 on one side of the equation, so I don't need to simplify it all. So we're going to have a equals 8, b is -2, c is -1. So we can go x equals, and we'll have -b plus or minus square root b squared minus 4ac all over 2a. Now, it may be tempting to go fast with plugging in these values, especially when you get the routine down, but the most common mistakes come with just plugging in things incorrectly. So take your time with it, focus on it, plug in carefully, and then you can just simplify down. But if things are plugged in incorrectly, you're going to get incorrect answers out. All right, -b. So -2 is our value for b, and then b squared, so -2 squared. And this is where our parentheses are super important, because that negative, like in this case, those negatives will cancel out to a positive, so that's important to see. All right, -4ac all over 2a. All right, if I think in terms of kind of these three pieces, so -2 makes it +2, then we'll have plus or minus our square root, and I just want what's underneath that exponent there. So I'll go -2 squared. And with this, I know a lot of this we can probably do in our head, but again, actually I'm doing that wrong. Okay. Again, if you just type it how it's written down on your piece of paper, then you know you have it right. So if anything, you can do the math and then check it with this method later. 4 times 8 times -1, so that's a +36. So we're getting a square root of 36 there, all over 2 times 8, which is 16. So we can simplify that square root. So this is the same thing as 2 plus 6 over 16. Sorry, plus or minus. And with that, we can separate into our two scenarios. Since we don't have that square root, we're not going to have anything trapped like we did in the first example. So what I'm going to do is separate into our two cases here, where x equals 2 plus 6 over 16, and where x equals 2 minus 6 over 16. And then we'll just simplify. So 2 plus 6 is 8, so 8 over 16, and then just reducing that fraction, that's x equals positive 1/2. 2 minus 6 is a negative 4 over 16, so that will be a negative 1/4. And there's our two solutions. So with that, we'd want to get to those two cases because we have nice whole numbers that we can actually work with and simplify down. So where the first case had some different ways of expressing the answer, this one really has that fraction form. If they asked for a decimal, then we could quickly change those to decimals with a 0.5 and a negative 0.25. All right, our next one here. So x squared plus 7x equals negative 2. So we want 0 on one side of the equation, so I need to add 2 to both sides of the equation. So we'll have x squared plus 7x plus 2 equals 0. And with that, we'll have a equals 1, b equals positive 7, and c equals positive 2. Also, you don't have to color code these like I am. I'm trying to make it clear since we're not in a classroom together, so making sure you can track the numbers easily. You don't have to use color pens for this, but I do really like it for keeping it organized and kind of visually making sure things plug in to the right places. So, all right, x equals negative plus or minus root squared minus 4ac all over 2a. All right, negative b plus or minus square root of b squared minus 4ac all over 2a. All right, so we'll have a negative 7 plus or minus square root of, and then we'll just type that into a calculator. So a 7 squared minus 4ac, so minus 4 times 1 times 2. So we're getting a square root of 41. So I can already start thinking that's not really going to simplify at all. So I'll stay a square root of 41 all over 2. So we can leave it in that form, or if we wanted to, we could split it up as negative 7 over 2 plus or minus square root of 41 over 2, either way. Or if we needed the decimal forms, we could plug it into a calculator. All right, one more example here, and this one has a lot of work to do before we can even apply the quadratic formula. So with this, I need to start simplifying. So first thing I'm going to do is FOIL. So I'm going to do first, outer, inner, last. So 2 times x times 3x is 3x squared. Negative x plus 3x, so that should simplify to a plus 2x. And then 1 times negative 1, so minus 1, equals 1. Now I'm going to distribute the 2 in. So we'll have 6x squared plus 4x minus 2 equals 1. And now I can subtract 1 from both sides. So we end up with 6x squared plus 4x minus 3 equals 0. So we have a equals 6, b equals positive 4, c equals negative 3. All right, so x equals, I'm going to get my format written down. All right, negative b plus or minus square root of b squared minus 4ac all over 2a. All right, x equals negative 4 plus or minus, and then for my square root, I'll go to my calculator. So a 4 squared minus 4 times 6 times negative 3. So that's a positive 88. All over 12. Now what I'm going to do here is I'm going to simplify down that square root of 88. Right? So square root of 88, and how we simplify radicals, and sorry, I'll just make this clear, this is kind of side work here. So simplifying radicals, what you want to do is think about the factors, and you could go as far as writing out the prime factorization of the number. What I do is I just try to think of numbers that are squares that can divide into it. So like, well, 1 isn't very useful, but 4, 9, 16, so on and so forth. So 4, I can tell, divides into that. So I could have a 4 times 22 to split that up. So that would give us 88. And then once I do that, what can be nice is then I'll look at that 22 and think about the factors of 22. It's like, well, I'd have a 2 and 11. There aren't any squares that go into 22. So this tells me I'm kind of done. So square root of 4 is 2. So that 2 can come on the outside, but that square root of 22 is trapped inside. So what I'm going to do is rewrite this as x equals, and I'm going to go ahead and split up my fraction. So negative 4 over 12 plus or minus, instead of square root of 88, 2 root 22 all over 12. And then by separating, what I can do is I can see simplifying my fractions. So like the negative 4 over 12, I can divide out a factor of 4. So I'd have a negative 1 over 3. Plus or minus, and then 2 divided by 12, so I could take out a common factor of 2 there, so I'd be left with a square root of 22 over 12 divided by 2, which is 6. So this would be our completely reduced form for our solution. Reducing our fractions, reducing our radicals, so we can get to that answer.